Hi, this is your instructor, Brad Roth, and I am recording a video tape of a short lecture to see if this will work in case we have to go to online classes. I just want to tell you that as of right now, which is 11:45 a.m. on Wednesday, we haven't gone to online classes, but MSU just went there, and I wouldn't be at all surprised. So let's give it a try and see if this is going to work. So we're going to analyze a thin lens. Again, the goal is not so much to analyze this problem, but to see if we can make the video production work. So you start off with a thin converging lens, and it's going to have a focal length of 3 centimeters. So you draw an optical axis along the center, and you put a 3 centimeters away on each side. That's the focal point. And your object is over here at 4 centimeters. Our goal is to analyze and draw the 3 rays. So let's give that a try. Here's the first ray. You have start at the top of your object, and you come parallel. You come in parallel, and when it goes through the lens, it then it changes directions and goes through the focal point, down here through this focal point and out. That's ray 1. Now this picture shows ray 1 plus ray 2. It starts at the top of the object and goes through the focal point and then down to the lens, and when it hits the lens, it goes out parallel. There's a third ray. So this has ray 1 and ray 2 plus ray 3, starts at the top of the lens and it goes through the center where the lens hits the optical axis, and it goes through that undeflected and continues down. Now, these rays are all coming down. They look like they're going to meet, but unfortunately it's off the paper. Sometimes this happens when you start drawing your picture. You make it too large or the paper's too small and you can't fit it all in. But it sure looks like these rays are going to come down here and meet somewhere out here about. So let's see if we estimate what the image distance is. Well, this distance from here to here is 3 centimeters. So it'd be about to 6 here. I'd estimate we're out here somewhere. I'm going to guess somewhere between 12 and 15 centimeters would be my predicted image distance. Also, it's pretty clear the image is going to be upside down. So it's going to be an inverted image. It's going to be real because the rays are all meeting out here. They're all meeting at a point. If you put film there, you could develop that image. And it looks to me like it's going to be magnified compared to the object. So I'm expecting a real inverted magnified image. Those are the 3 rays. Now let's do this analytically. Okay, we're going to start with a 3 centimeter focal length, 4 centimeter object. We're going to use the thin lens equation. 1 over the focal length equals 1 over the image distance plus 1 over the object distance. So we'll solve for the image distance and get the image distance is 1/3, 1 over the focal length, minus, and we'll bring the object distance to the other side of the equation, 1/4, 1 over the object distance. We'll put it over a common denominator, over 12, so you'll get 4 minus 3/12, or 1/12, and the final answer is the reciprocal of that, 12 centimeters, which isn't bad. We were estimating 10 to 15 centimeters. 12 centimeters is right in the right ballpark. Magnification is minus di over do, image distance over object distance. So there's our minus sign. The image distance we found was 12 centimeters. Object was 4. We get a minus 3 for the magnification. Now, let's review this a little bit. The fact that the image distance is positive is consistent with the image being real. Real images tend to have positive image distances. And the fact that the magnification is negative is consistent with the image being inverted. Negative magnifications mean an inverted image. And the fact that the absolute value of the magnification is bigger than 1 means that it's a magnified image. It's actually magnified to 3 times its size. So, again, the goal isn't to do a thin lens problem. We've done that in class. The goal is to see if we can get this recording, you can view it, and we can use this as a way to do online classes. So now I've done this video twice before. I haven't managed to figure out how to save it. So now I'm going to try to turn it off and hopefully save this video. Save as movie recordings. I'm going to save as desktop.